Okay, so today we're going to learn about hyperbolas. And hyperbolas are basically two parabolas that are going opposite directions. It helps if I can spell, doesn't it? All right, so you have a hyperbola that looks like this, which this one's going pointing like the x and y axis goes. Okay, and that's kind of going to be important for what we're going to be doing here. So the equation for a hyperbola that's doing this, going left and right, okay, is x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Now, these numbers before with an ellipse, it mattered which one was larger. With a hyperbola, it doesn't matter. It's which one is first because you're talking about subtraction. When it's addition, the order doesn't matter. 3 plus 2 is the same thing as 2 plus 3. When it's subtraction, 3 minus 2 is different than 2 minus 3. So that's kind of important, okay? With this type of hyperbola, it's kind of the same way that an ellipse rolls. The center is still h and k. The vertex, or the vertices I should say, let me write that out over here, vertices, would be h plus or minus a, k, because again it would go with the x-axis, okay, because we're going here, so our vertices would be here and here, okay. Now, I'm going to say co-vertice here. It's not really co-vertices. That's not what they're really called. They're never really mentioned as anything, and if you look at the formulas in the book, it doesn't say co-vertices. But we're going to use that instead of drawing asymptotes with this stuff. And I'll talk about that here when I start graphing this stuff. So that would be h, k, plus or minus b. So same idea as an ellipse. It's basically the same thing, okay? Your foci, again, would follow your C rule. So let me do the C rule first. So since this is subtraction, to find C, we're going to do a squared plus b squared equals c squared. If you remember with an ellipse, this was addition, so this was subtraction. Okay, vice versa. This is subtraction, so this is an addition. So my foci, again, will follow my vertice value. So it would be h plus or minus c, k. So that's what in a hyperbola that is going in left and right form. Okay. If you want a hyperbola that's going up and down, again, it's basically the same idea as an ellipse. All right, your formula is going to be y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Okay, so notice the only thing that's really changed in this is the x and y have switched, and if y comes first, it's got to point up and point down. Okay, my center is still at hk. My vertices are now h, k plus or minus a. So again, now we're changing our k value because the a squared is underneath k. Here the a squared was underneath h, so we changed our h value. Our co-vertice, again, it's not really called that, but we're going to use it here a little bit, is h plus or minus bk. It's still the same, a squared plus b squared is equal to c squared. And then our foci are h, k plus or minus c. And again, the same idea as an ellipse. Your vertice and foci are always going to be connected to each other. Your foci now, though, are going to be on the outside, or like eating, like the Pac-Man's eating the dots. Okay, so again here, there's going to be my foci, there's going to be my foci. Okay, so I'm going to do a couple examples and hopefully help you out with this stuff.